Welcome to video 09, more division in modular arithmetic. We've got 3 problems. The first problem states that 20 is congruent to 2 mod 6. We're going to now properly divide each side by 2. This was the example used before where we did it incorrectly. So notice this. This is 10 times 2, 1 times 2, 3 times 2. So the greatest common divisor of this factor I'm dividing by in this is 2. So remember, divide by 2, divide by 2, divide the mod by the greatest common divisor, which is also 2. So just divide by 2, divide by 2, divide by 2, and I'm going to get 10 equals 1 mod 3. And that's how the general division formula worked. All right, a couple more problems dealing with solving equations. I'm not going to go into the more complicated inverses and things like that. I'm going to keep it basic. So if you want to investigate that further, you can always Google it, but this should be good enough for us. All right, solve for x. All right, there's a factor of 3 here, a factor of 3 here, no factors of 3 here. So this mod, and what I'm going to divide by, is relatively prime. So then normal division works. So divide by 3, divide by 3. Basically, the greatest common divisor is 1. Divide that by 1, no big deal. So I'm going to get x is congruent to 4 mod 7. Okay, final example. 3x is congruent to 4 mod 7. All right, first off, I've got a factor of 3 here. I do not have a factor of 3 here. So I can't divide by 3 and get 4/3. That's not an integer. In number theory, it's all about integers. What I can do is if I'm in mod 7, just keep cycling through adding 7s till I do get a multiple of 3 and then perform my division. And that's what I'm going to do. So again, when you're in mod 7, you can just keep adding or subtracting as many 7s as you want. So this is the same as 3x is congruent to 11 mod 7. No factors of 3 there. Add another 7. 3x is congruent to 18 mod 7. Now I do have a factor of 3 there. So I'm going to divide through by 3. There's no factor of 3 in the mod, so I can use quote-unquote normal division. And my answer will be, I don't know if I have room, I'll go over here. X is congruent to 6 mod 7. And if for some reason this wasn't the smallest non-negative integer, I would mod out to make it so. That's just the convention I use. So there you have it, how to solve some division problems in modular arithmetic.